The next piece of information is its straight line distance from its initial starting point to the top of the lantern, which is here. So this distance is 620 metres. So once you've got the box, oh, I forgot to draw the top of the box, sorry. Once you've got that box, really what you're doing is you're turning it into a right angle. So you want this distance eventually, you've got to make a right angle triangle. So the easiest way is to make one here with that vertical height, because that's what we want, okay? So if we can find this diagonal along the ground using Pythagoras, okay, then we can use Pythagoras backwards in order to find the height, okay? Some people find that a little hard to follow, so there's another way of thinking about it. But here is my starting point, and my lantern is obviously in the sky from that starting point, okay, or it gets released. Then it travels east, the 205 metres, then it travels north, the 180 metres, and it ends up in that spot. So my lantern, I don't even know what a sky lantern looks like, to be honest, but let's just draw a lantern because it looks cool. Okay, so from my ground, okay, the lantern's gone up, so it's been released up, then it's travelled and ended up over here. And so then we've got the same thing, we just fill in the 3 dimensions around those points, okay, and we're trying to find that we've got the distance from the starting point to the corner, and we want this height, so this direct height, so we need to create this right angle triangle, and we need to find that using that 205 and that 180 metres. So either way, you kind of end up with the same diagram, but it's just kind of the way you think about it.